Okay, moving on to 10.4b, we looked at polar equations, and now we're going to be looking at polar equations and derivatives. But before we jump into the calculus of polar, we need to develop some proficiency converting back and forth from polar to rectangular coordinates and equations. So rectangular coordinates are in the form of xy, where x is the independent variable. Polar coordinates are in the form of r theta, but these variables are kind of out of order. Theta is going to be an independent variable, but it's going to come second when we list them out. Okay, so for coordinate conversions, from polar to rectangular, x is equal to r cosine of theta, y is equal to r sine of theta, and that's coming from a right triangle where we have a horizontal component of x, y being the vertical, r being the hypotenuse. We can think of sine of theta as y over r, cosine of theta as x over r, and if we solve for x and for y, we get x equals r cosine theta, and we get y equals r sine theta. So if we have the r and theta, we can always plug those in to separately find x and y. Okay. Now from rectangular to polar, again, we look at our diagram here, but now we think in terms of Pythagorean theorem. X squared plus y squared equals r squared. So if I want to solve for r, I take the square root of both sides. So r is equal to the square root of x squared plus y squared. So if I have my x and y values, I can plug in, and that will give me my radius for my polar coordinate. And to get to my theta, well, I know that tangent of theta is equal to y over x. So if I have my y and x value, then I can say inverse tangent of y over x is equal to theta. So I can always use inverse tangent to plug in y and x to get my theta. And if I have my theta and my r, then I have my coordinate points for polar form. So let's practice through some of these here. Example 1, convert the following coordinate as specified. Convert 5 pi over 6 to rectangular coordinates. Well, our conversion form is r cosine theta for x, and for y it is r sine of theta. So theta is 5 pi over 6, r is 2, so we plug those in. 5 pi over 6 for cosine will produce negative root 3 over 2. 5 pi over 6 for sine will produce 1/2. So we combine this to be negative root 3 and 1, so our x and y ordered pair will be negative root 3 and 1. And that should make sense because 5 pi over 6 will take us to the second quadrant with going out 2 units. And my ordered pair, negative root 3, 1, also makes sense in the second quadrant. Okay, going from rectangular to rectangular coordinates to polar coordinates. Convert 3, negative 3 to polar coordinates. Well, it helps if we can sketch that, plot that point. So 3 over 3 down. So here's our ordered pair. So we can think of this as the hypotenuse. The hypotenuse, we can eventually think of that as the radius. So r is equal to the square root of x squared plus y squared. And that will get us to 9 plus 9, which is 18. Square root of 18 is 3 root 2, so that's my r. Tangent of theta is y over x. So y over x is negative 3 over 3, which is negative 1. The inverse tangent of negative 1 is going to be 7 pi over 4 in the fourth quadrant. 7 pi over 4 will be my theta. So my r theta will be 3 root 2, 7 pi over 4. Or remember that we can simply subtract any multiples of 2 pi to get equivalent points because of coterminal angles. So we can go the other direction, 0 minus pi over 4, which will be negative pi over 4. So 3 root 2, negative pi over 4. So we have many different ways to represent the same point in the polar form. All right, example 2. We've converted coordinates from one form to the next. Now we need to see if we can convert equations from one form to the next. So y is equal to 2x plus 1. We want to convert this to polar form. So we know what y can be represented as r sine of theta. We know x can be represented as r cosine of theta. So we simply make our substitutions. Y gets replaced with r sine of theta. X gets replaced with r cosine of theta. Okay. We make this 2r cosine of theta, and we can bring try and put the r's together. So move the 2r cosine of theta to the left side. Factor out the r. We have sine of theta minus 2 cosine of theta. And then we want to just solve for r if we can. Okay, so solve in terms of r. And so when we solve for r, we get r is equal to 1 over sine of theta minus 2 cosine of theta. We have eliminated y and x, and we have converted all of our variables to be in terms of r and theta. Okay, another one that we can need to convert from rectangular to polar, y is equal to 4. Well, we know y can be represented as r sine of theta, so r sine of theta is equal to 4. We want to solve for r if we can, so divide by sine of theta. And we do that, we get r is equal to 4 over sine of theta. X squared plus y squared equals 16. Okay, again, converting from rectangular to polar. So x can be represented as r cosine of theta. Y can be represented as r sine of theta. Okay, we square both to get r squared cosine squared, r squared sine squared. Factor out the r squared. We have cosine squared plus sine squared. We know the Pythagorean identity here. This will produce 1, so r squared equals 16, so r is equal to 4. And it makes sense, right? This means that we have, that means for all values of theta, all the angle values, we're going to have, for each angle value, we're going to create a radius of 4. So for every possible angle measure, we have a radius of 4 that will create a circle. Okay, convert equations from polar to rectangular now. Okay, so now we're going to try and replace all of our r and theta in terms of x and y. Right. So usually what we want to do here is we want to try and replace the trig portion first. If we can replace the trig portion in terms of x and r, or y and r, the r will usually take care of itself later on. So cosine of theta, we can replace that as x over r, because we know that r is equal to x is equal to r cosine of theta. So cosine of theta will just be x over r. Replace cosine theta as x over r. Move the r to the right side. R squared is equal to 2x. So once we have r squared, now we can replace that with x squared plus y squared. So now we have everything in terms of x and y. Clean this up a little bit more. We can complete the square if we like. Make it x minus 1 squared plus y squared is equal to 1. Or y squared equals to 1 minus x minus 1 squared. Okay? Either way, it will produce a circle of radius 1. All right, next we have theta is equal to 3 pi over 4. So let's see if we can graph this. That may help us a bit. So theta is 3 pi over 4. That's going to be a reference angle of pi over 4 in the second quadrant. And you see that this line is going to be basically a 45-degree line with a negative slope. So this looks like a y equals negative x, right? This line here. Okay. So basically saying for any radius with a angle of 3 pi over 4, well, any radius of any radius with an angle of 3 pi over 4 will produce all these values here and negative values down here. So we'll just create this line. Okay, so we should get y equals negative x. So let's see if we can get there. Theta is equal to 3 pi over 4. Let's take the tangent of both sides. Okay, that will kind of help us to convert it a little bit further. So tangent of theta is equal to tangent of 3 pi over 4. Well, tangent of 3 pi over 4 is simply negative 1. Tangent of theta, we can replace that with y over x. So y over x equals negative 1. Solve for y by bringing the x over. So y equals negative x. Okay, finally part C, r is equal to cosecant of theta. Cosecant of theta is same thing as 1 over sine of theta. Sine of theta is y over r. We flip that, we get r over y. And we move things around, get ry equals r, divide both sides by r. R over r is 1, so y is equal to 1.